Today I have got another problem for electromagnetic theory. This appeared in Electronics and Communication paper of GATE 1998, and this is not a multiple choice question. You have to answer three questions here, and here is the question. So the electric field vector of a wave is given as, so there is this equation of the electric field, and its frequency is 10 gigahertz, and we have to investigate if this wave is a plane wave, and we have to determine the propagation constant, and also we have to calculate the phase velocity in y direction. Okay, so let's get into the answer. So before that, if you have not subscribed to our channel, please go ahead and subscribe to our channel for more such problems and solutions. So in this problem we have to find out whether the given wave is a plane wave. So what is the most important characteristics of a plane wave? A plane wave has its electric and magnetic fields which are orthogonal to each other, as well as the electric field is orthogonal to the direction of propagation. So this is one of the basic concepts of electromagnetic theory, and that case, if we say that propagation constant, which we say like beta, which is a vector, and this one is orthogonal to the electric field vector, which is E. Uh, in that case, the given wave is a plane wave. Okay, so first we have the electric field vector, which is given here, and from this we can infer a couple of things. First, we can see that we can find out what is the propagation vector beta. Since in this question there is no mention of the medium in which it is traveling, and it's only the frequency is the one which is given. So in that case, I will just assume that the propagation constant is just beta, and the propagation vector is beta, and the propagation constant is magnitude of this vector. So this is propagation vector, and the magnitude is propagation constant. So the electric field, any electric field of a plane wave can be expressed like this, that is E is equal to E naught e raised to, so E naught is a vector here, the electric field vector, e raised to minus j omega t minus the propagation vector and the r vector direction. So we know from the given expression, omega t minus the beta dot r dot is given by this expression here. So that means that beta dot r is given as beta dot r is given as minus 3x plus 4y. We know that r is x ax plus y ay plus z az. By comparing comparing this and this, we see that the propagation vector beta can be given as beta is equal to minus 3ax plus 4ay. Okay, so we found out what is the vector beta, and we know from the given problem what is the electric field vector, which is given here. So the electric field vector, which I will just denote as E vector, is given as 8ax plus 6ay plus 5az. and there is a term outside here. So we have this part cleared, and then the next thing is to find out whether these two vectors are. So once we know once we found out these two vectors, now we have to find out whether these two are orthogonal to each other. So this is the electric field vector and this is the propagation vector. If these two are orthogonal to each other, that means this is a plane wave. So in that for that, what we have to do is to find the dot product of these two. A dot product of two orthogonal vectors is always 0. So let's just do that. Let's ignore this this part here. So just beta dot E is equal to. So once you do this, it's minus 24 plus 24 plus. So if you assume that there is just a 0 component here, which is AZ, so this becomes 0. So beta dot E vector is 0. This means that this is indeed a plane wave. Okay, now let's solve the second part. The second part is to determine the propagation constant of this wave. The propagation vector, which we saw from the previous solution of the first question, we saw that propagation vector is 3ax plus 4ay plus 0 az. So we know that. So the propagation constant can be simply determined as the magnitude of this vector, which is 3 square plus 4 square plus 0 square, which is 5. So the propagation constant in this case is just 5. And the third question, if we go to the third question, we have to find the phase velocity in y direction. So we know that the velocity, which is the phase velocity, can be given as omega by beta. But in this case, we have to find it along in the y direction, since in that case, what we have to do is to find beta phase velocity in y direction, which is omega by beta y. We know what is omega. Omega is 2 pi into frequency divided by beta y. So frequency is already given, so it's 2 pi into 10 gigahertz and divided by beta y. So now we have to find what is beta y. So for this, let me just draw this vector on a two coordinates, which is x and y, and the vector is minus 3ax, which is in this direction, so it's minus 3ax, that's plus 4ay, and this is somewhere like this, so it's minus 3 and plus 4. So in this case, this angle theta, which is given as theta equal to tan inverse of 3 by 4 theta, so theta becomes 30. If we calculate this, it becomes 36.9 degrees. So in that case, the beta y, which is in this direction, this is beta y. So if you say this is beta y and this is beta x, so beta y is given as beta cos 36.9 degrees. So if you solve this, so beta y comes out to be 5, comes out to be 4. So plugging this in this equation, we get the phase velocity, that is Vp equal to 5 pi into 10 raised to 9 meters per second, which is quite possible because this is the phase velocity which you are calculating. The group velocity, however, can't go above the velocity of light, which is 3 into 10 raised to 8 meters per second. But since we are calculating the phase velocity, this could be a correct answer. I have not checked the answers for these questions, and I might be wrong in these solutions. So please tell me in the comments below if you have gone wrong or if I have made some mistakes, because there is one more solution, one more way in which we can solve this, where the propagation constant is given by just the propagation constant can be given by beta is equal to omega by c, and c is or omega mu epsilon. But in the given question, what it appears to be is that there is no mention of any medium. In that case, it could be in the free space. In that case, we know what is c, the what is mu epsilon, root of mu epsilon, which is just root of mu naught epsilon naught, that is c, and in that case the beta turns out to be a different number. But since there is no mention of medium, I thought we have to just find out the beta from the given expression here, and the solution follows from there. But I'm not sure yet, but you have to find out the correct answer and let me know in the comments. Thanks for watching, and please subscribe to our channel if you have not done so, and also check out the description below where I recommend other channels to watch, and also some books that you can check out for solving electromagnetic problems.